Well, hello class. Welcome to 17.1, number 1. Now, a long time ago, we figured out exactly how much energy you use every day. I found out that being a large and semi-active person, I use over 13 million joules of energy every day. And you may have thought you could forget this. Well, you can't. So, in case you lost that number, just take your daily calorie income, multiply it by 4,186, and you should find out how many joules you use every day. Now, what I want to find out is if I could plug myself into an outlet, how much charge would have to run through my body? What would be the minimum charge that would have to run through my body? So let's start out with our formula here. So the potential energy that we'd be trying to store up electrically in my body somehow, if I could plug myself into an outlet, is going to be equal to Q, the charge that's going to have to run through me, times delta V, the voltage, which in America and Mexico and Canada and some other places is 120. By the way, if you're in Europe or Asia, that number is going to be 240. But in the US, it's 120. So let's start up. So my energy is 13,710,000 joules. Yes, I'm a big boy and I use a lot of energy every day. The charge we're trying to find, and the change in voltage in the United States is 120 volts. Now, by the way, there is some variety. Some parts of the US it's down like about 110. You might be a place where it's normally 120, but there's a lot of people doing stuff and the grid is kind of struggling a little bit. It might drop down to 110. We're just going to say 120 volts, okay? And again, if you're in Europe or Asia, the number will probably be about 220 or even up to 240, depending on where you are. Check your local power company. So let's get started here. So it's actually a fairly simple equation when you think about it. Divide both sides by 120. And what you end up with is, what do you end up with? Well, anyway, I did this calculation and I found that approximately 114,250 joules, coulombs, charges in coulombs, would have to be the number of charges that go through. Now, a couple things to point out. One, 2 sig figs, more than 2 sig figs, we're going to have to round this, so I'm going to round it to 110,000. How did that get there? 110,000 coulombs is the charge. But let's think about this for a second here. I don't know if you've ever recharged anything before. This would be the amount of charge if I were running electricity, but most things charge at a higher voltage. A lot of energy is usually lost in charging. So, this is the minimum. In reality, if I charge as efficiently as most of our batteries, number could easily be 200,000. But for what we're doing here, just trying to practice using our equations, this will work. Assume your daily energy divided by 120. Assume that the electricity grid is working well. And there you go. Now, by the way, if you're a bigger person than me, you're going to have a bigger answer. If you're a smaller person than me, you're going to have a smaller answer. If you're less active, expect a smaller number. And again, if you're in Europe or Asia where the acting voltage is higher, you're going to be dividing by a bigger number. Definitely if you're in Europe or Asia, and I know at least one of you are, expect a much smaller number. You double the voltage, you're going to pretty much cut the charge in half, okay? Well, anyway, I hope you enjoyed this. See you later. Bye-bye. And don't try this at home. Danger.